Hello students, welcome to my channel Positron. Undoubtedly this channel is dedicated to those who are preparing, who are the aspirants of NEET, IIT, or the students of uh, any board 11th and 12th. This channel is dedicated for the physics. Last few days I made many videos and posted them. Dear students, we have discussed in last video about the relative velocity in one dimension and not river boat problem or rain man problem or airplane wind problem. These are the part of relative velocity in two dimension. Really, I have discussed with you the topic, the articles related to the river boat problem in the last video. So today is that on those topics we will solve some very important problems, some very famous problems, some problems that are might asked in many examinations, that are the part of many examination papers. Dear student, one question is a very generally it is asked. The problem is that a man can swim in still water with velocity 3 km per hour and river is flowing with velocity 2 km per hour. Find the direction in which man should sail so that he reaches just to opposite point and also the time taken in crossing the river. Dear students, this is the problem that a man can swim in still water with velocity 3 km per hour and river is flowing with the velocity 2 km per hour. Find the direction in which man should sail so that he reaches just to opposite point and also the time taken in crossing the river. This question I have taken from S.C. Verma sir book SCV, but dear student, this is a very general question and many times it has been asked in the examination. Dear student, the important part of this question is that generally often I have seen that students are very much confused that whether it is a velocity of man with respect to river or what is the velocity of man with respect to ground or what is the velocity of river with respect to ground. You know, motion is not an absolute thing. Absolute means a physical quantity which can be defined independently. Motion is not an absolute thing. It cannot be defined independently. It must should be defined with respect to an observer. Okay, it should be defined with respect to observer. That observer is the frame of reference. Now, I'm trying to solve this question. Look here. This is the river and here is a person looking all that process what is happening here. River is flowing in this way. This is the velocity of river and that is given 2 km per hour. And this person will observe that river is flowing in this way. It means it is a velocity of river because he is on the ground. So it is the velocity of river with respect to ground. Now, man want to sail from A to B. B is directly opposite to the A. His objective is to begin the sail from A. He begin to swim from A and he has to reach B. You know, the general perception from common sense, you can say, if you will sail in perpendicular direction, you will not reach here. Rather, you will reach here or somewhere else, right? So, in order to reach here, what you will do? You will sail in the river. You will sail, man will sail in the river in this direction. Let this angle is theta. Okay, man will sail in this direction, and this is the velocity of man with respect to river. Man will sail with respect to river or in the river in this direction. So it is the velocity of man with respect to river, and then he will reach to point B, right? And let it is angle is theta from the vertical. And if the man sails in this condition, then he may reach to point B. Now what we have to do? We have to find out this angle theta, okay? And the time taken in crossing from A to B. Simply, dear students, if you want to find out the time, you can easily, T is equal to, time is equal to distance. Let this river is, the width of river is let 500 meter, and that is 1 by 2 kilometer. So this is D, that is 1 by 2 kilometer. Now dear students, time taken in crossing the river, time is equal to distance upon, that is distance upon velocity, perpendicular velocity, that is VMR cos theta. In this way, you can find out. Now look here. Dear students, what it is saying? A man can swim in still water with a velocity 3 km per hour. In still water, dear student, what it is given? Question is that what it is given, that man can swim in still water with a velocity 3 km per hour, whereas the river is flowing with velocity 2 km per hour. Now, this velocity of man is with respect to which frame of reference, with respect to which observer? It is saying that man can swim in still water with velocity 3 km per hour. Dear student, you must have studied the velocity of A with respect to B is equal to VA minus VB. This is a general formula you use while you are studying the relative velocity. That is, velocity of A with respect to B is equal to VA minus VB. Now question is that what is the velocity of A with respect to B? What is means of that? It is means that velocity of A with respect to B, it means that what is the velocity of A when B is at rest? This is the mean. VAB is equal to VA minus VB. It means what is the velocity of A when B is at rest? This is a very important thing, and this will help you in relative velocity problems. That VAB is equal to VA minus VB. It means that velocity of A with respect to B means what is the velocity of A when B is at rest? Let the two trains are moving in same direction with velocity 100 km per hour, right? These are the two trains A and B. They are moving with the velocity 100 km per hour, right? And the distance between them is 50 km, right? Dear students, VAB means when B is at rest, then what is the velocity of A, right? This is 0. How? When they are moving in same direction, VA minus VB, you will put 100 minus 100, that is 0. What is means of that? How will you explain it with the relative velocity? When they are moving, in 1 hour, it will travel 100 km. In 1 hour, it will also travel 100 km. Again, initially, the distance between them was 50 km, and even after the hour, the relative distance between them is 50 km. So, there is not a relative displacement. Initially, the distance between them was 50 km, and even an hour after, the distance between them is 50 km. It means there is no relative displacement. That is why velocity of A with respect to B is 0. Velocity of what is motion? Motion means relative displacement. If the relative displacement with the time between the two bodies is zero, then the A is at rest with respect to B. Why it is here in this case BAB is equal to 0? Initially they were 50 kilometer apart. Even after an hour they are 50 kilometer apart, because in 1 hour it will travel 100 kilometer. In 1 hour it will also travel 100 kilometers. So again the displacement, the distance between them is a 50 kilometers. So there is no relative displacement. That is why A is at rest with respect to B. Now interesting becomes when you ask that the two trains with 100 kilometer per hour, they are traveling in opposite direction. Now what is VAB? Now dear students, in this case it is a question of relative velocity in one dimension, you can say. Now this is 100, right? This one is moving with velocity 100 kilometer minus VB. It is, this time it is coming in negative x direction, so minus 100. Now it becomes 200 kilometer per hour. Dear students, it means VAB. Initially, the two trains are moving with velocity 100 kilometer per hour and they are approaching to each other. Now, if B is at rest, then A has to travel with velocity 200 kilometer per hour. We say VAB is velocity of A with respect to B. Means, what is the velocity? What should be the velocity of A when B is at rest? Now, in this case, if the two trains are traveling, approaching to each other with a velocity 100 kilometer per hour, then if B is at rest, then to match that condition, A has to travel with a velocity 200 kilometer per hour. This was the basic concept. That is why I was working on this. Now, dear students, look here. A man, our problem is that a river is a half kilometer wide, right? River is flowing with 2 kilometer per hour, and question is given that a man can swim in the river in still water with velocity 3 kilometer per hour. In still, man can swim in still water. Means velocity of man when water is at rest, river is at rest. It means it is given the velocity of man with respect to river. So dear students, you are given VMR and that is equal to 3 kilometer per hour. Right? Now, you simply can apply, you have now the basic condition that when you have to reach from A to B opposite, exact in opposite direction, what will you apply? Now look here, it's a river is flowing in this way and its horizontal component will be VMR sine theta. Now look here, for exactly man wants, if the swimmer wants to travel from A to B exactly in opposite direction, then this horizontal component should be balanced. And so VMR sine theta is equal to VRG. Now VMR is that is velocity of man with respect to river, that is 3 sine theta, and VRG is a 2, so sine theta is equal to 2 by 3. Now, or you can say theta is equal to sine inverse 2 by 3. Means the man should make an angle sine inverse 2 by 3 from the vertical so that he should begin his swimming and then he will reach in opposite direction, just opposite to A. Right? Now, what we have to do, dear student, now we have to find out, you find sine theta, right? So now what we have to find out that how much time will it take. Now dear student, look here. Time t is equal to d upon VMR cos theta, right? If sine theta is given, now this is a theta, sine theta is a perpendicular upon hypotenuse. So what is this perpendicular upon hypotenuse? That is 2 by 3, and so it will be under root 9 minus 4 means this is root 5, right? So cos theta is equal to base upon hypo root 5 by 3. So, time t is equal to d upon VMR cos theta. D is a 1 by 2 upon VMR is a 3 into root 5 by 3. 3 would be cancelled. So, 1 upon 2 root 5. This R. This is the R. The time taken in crossing the river, T is equal to 1 by 2 root 5 R. Right? What I have done? Time is equal to distance upon perpendicular component of velocity. Perpendicular component of velocity is a VMR cos theta. VMR is a 3. And this is sin theta, we have find 2 by 3. So cos theta will be, so this will be under root 3 square 9 minus 4 root 5. So cos theta is equal to root 5 by 3. So ultimately we have got that time taken in crossing this river is equal to 1 upon 2 root 5. Dear students, some problems, these problems I have considered from S.C. Burma's book, SCB first part, and this is my own opinion that if you are a beginner in physics, then after the NCERT you must go. But rather I'll say that if you are preparing for NEET and JEE, then you should move further along with the NCERT with the SCB, right? Both the book you should follow, and then you will work. It will work. This idea might work. I'm very sure. Next problem, that is again I'm taking the problem I have considered from S.C. Visar book. Problem is, a man can swim, in short I am writing, a man can swim in still water with a velocity 3 km per hour. Means velocity of man with respect to river it is given. He wants to cross 500 meter wide river. Again it is a 500 meter wide river, right? 500 meter wide river means 1 by 2 kilometer. And again the velocity of river with respect to ground, that is equal to 2 km per hour. He keeps himself always at an angle 120 degree. That is velocity of man with respect to river, that is 120 completely. This angle is a 120. So it is a 30 degrees. Find the time taken in crossing the river. At what point on the opposite bank he will arrive? Question is that. Again, find the time taken in crossing the river. VMR is given. It's a very simple problem. Nothing you have to do. Right? Time is equal to distance. The width of river is a 1 by 2 kilometer. And the vertical component of velocity of man with respect to river, vertical component of velocity of swimmer, that is VMR cos 30. So 1 by 2, VMR is a what? VMR is a 3, cos 30 is a root 3 by 2, right? So these two cancel, 1 by 3 root 3, that is R. This would be the time taken in crossing the river. Now what he says, that how much horizontal distance he covers. When he says, this time the question is a different. It is not saying that he reaches from A to B, right? Let he reaches somewhere here. Dear student, one thing is very important. The man begin to swim. A man keeps always 120 degree himself at 120 degree with respect to river, right? But what happens? River will sail this man, throw this man. He will not reach here. He might reach here, but this time let he reaches at point C, right? Now the question is that what is the drift traveled by the man? Means what is during the sail, during crossing the river, what is the horizontal distance covered by the man? Very simply you can say, you can solve it. The horizontal net horizontal velocity, net horizontal velocity this is 2 kilometer per hour, and this is a horizontal component will be this VMR sine 30, right? Yes, one thing is very important, very simple thing I'm telling, it makes you to think very simple. Let this is R and this angle is theta. Then this component adjacent to angle is a cos, and the component away from another perpendicular component away from the angle, that is a sine. This is r sine theta, right? If this is theta, then this is cos, this is sine, right? In the same way I used to do. Now look here, this component is away from the angle, so it is a sine. It is VMR sine 30. Now the horizontal component of velocity, net horizontal component of velocity becomes, this is 2 kilometer per hour, and this is you have to take negative bit. So VMR is a 3 again, and this is sine 30. 1 by 2, 3 by 2, 1.5, that is 2 minus 1.5, that is 0.5, and so it works out to be 1 by 2 kilometer per hour. Now, the net horizontal, what I have said just a moment before, I discussed with you, that if you want to cross the river, you need the vertical component. If you want to find out the horizontal drift during crossing the river, means how much horizontally he was drifted, the swimmer was drifted, you need the net horizontal component of velocity, and that is this. And so what happens, this is the net horizontal component of velocity. So drift, horizontal drift, you can say horizontal drift, that is equal to net horizontal velocity, and distance is equal to velocity into time. And how much time he was in the river, means how much time he taken, the swimmer taken to cross the river, and that was the that works out to be 1 by 3 root 3, and so 1 by 6 root 3, right? Horizontal drift is equal to velocity, horizontal component of velocity is this, and time taken in crossing the river is this, so 1 by 6 root 3. In SCV, it is solved in this way. Now, question is that how you can solve. There are many methods to solve this, right? Another method is how you can solve taking component of velocity in this way. In SCV, great Burma sir, how he has solved that, you say velocity of A with respect to B is equal to VA minus VB. I am discussing with you another method to solve it. VAB is equal to VA minus VB. Now, velocity of A with respect to B is equal to velocity of A minus velocity of B. But is it true to write velocity of A? Where is the frame of reference? With which frame of reference? Who is the observer to whom you are talking? Dear student, you have to take a common observer. You cannot write independently velocity of A or velocity of B. You have to consider a common observer. For that, let your ground is a common observer. You might write in this way, right? In the similar way, you can write velocity of man with respect to ground. You can write velocity of man minus velocity of river, right? Velocity of man. Take this velocity of man with respect to river, that is velocity of man minus velocity of river. Now, a common frame I am supposing ground, so it becomes VMG minus VRG, or you can say VMG is equal to, we are taking that side, VMR plus VRG. Dear student, velocity of man with respect, I have written VMR is a VM minus VR. Now, let velocity of man and velocity of river have been expressed with respect to ground. So it becomes this. VMG is equal to VMR plus VRG. Or you can write, now it's a good idea to write VMG is equal to VMR, right, plus VRG. In SCV, it is written in this way: velocity of man with respect to ground is equal to velocity of man with respect to river plus velocity of river with respect to ground. Dear student, let man be, now how it is solved in SCB I am discussing with you. Man is traveling with respect to river here. Let he reaches here. Who sees? To whom it appears that man has reached here? A man sitting on the ground, yet the boy is swimming, the man is swimming in the river in this direction, making 30 degree from the vertical or 120 degree from the horizontal. But what happens? He is drifted, he is sailed by the river and he reaches at point C. Now, he reaches to point C, but this man who is in the river, he will think, it will appear that he reached here because he is in the river. Means it is the velocity of man with respect to river. But he will reach here and it is observed by this man. The man on the ground who is sitting at the river bank, he will observe that actually the man has reached here. So it is the velocity of man with respect to ground. Man is traveling in the river in this direction. It is the velocity of man with respect to river. Ultimately, he will be drifted at point C, and it is observed by the man sitting at the river bank. He observes, this man observes that actually this swimmer has not reached here yet, rather he has reached here. It means it is the velocity of man with respect to ground. Now, dear student, VMG, you can write VMG is equal to this VMR plus VRG, right? Now, look here, let this angle is theta, right? Let this angle is theta. Now, dear student, take vertical components. If you take vertical component of all this, and what I am trying to let you understand, that how it is solved in SCV, in SC Verma sir book. I'm trying to explain that method also. Now look here, VMR is VM minus VR. The common frame of reference, let it is a ground. So you can write VMG is equal to velocity of man with respect. I have taken transform from here to here. So it is VMR plus VRG, right? You can write in this way: VAB is equal to velocity of A with respect to C plus velocity of C with respect to B. It can be written in this way. Now, dear student, take vertical component. Taking vertical component, what comes? Look here. Taking vertical component. Look here. It will be VMG cos theta. Right? And VMR, the vertical component of this is VMR cos 30. Now, it is a VRG. If you take, it is horizontal, so it is in horizontal direction. You can say it's a vertical component is 0, or you can say VRG cos 90, and cos 90 is 0. So it becomes 0. So this will be VMR is a 3, cos 30 is a 3, cos 30, or you can write 3 into root 3 by 2. Right? Now, dear student, vertical component of this you have got VMG cos theta, right? So, time taken in traveling, that is a distance upon Now velocity of man with respect to ground, you have to consider here Vmg, means how much time the man has taken with respect to ground, with respect to an observer sitting here, that in how much time this man sails, this man crosses this river, that is appeared by this, observed by this, means how much time this observer observes, that how much time this man has taken in crossing the river, calculated by this man, that is a k root 3, that is a T is equal to D upon Vmg cos theta. D is a 1 by 2, and so it is a 3 root 3 by 2. 2 we cancel 1 by 3 root 3. This is our. Now, what is the horizontal drift you have to take? For the horizontal drift, take is a horizontal component. Horizontal component is a, now look here it is. The horizontal component Vmg, that is Vmg sine theta, VMR, this is VMR cos 30, but in opposite direction, minus VMR cos 30 plus VR is 2, so 2 minus VMR is given 3, cos 30 is a, sorry, it is a VMR sin 30, I'm sorry. So again 1 by 2, right? So 1 by 2. So the horizontal drift, that is equal to, horizontal drift is equal to velocity, net horizontal velocity into time taken in crossing the river, that is 1 by 6 root 3. In this way you can solve it, right? Dear student, this was the second problem that I have discussed. Some more problem I will discuss with you. Next is a very common problem that is asked. This problem is, a man crosses the river in boat. He crosses the river in minimum time, takes 10 minutes. And drift is a 120 meter. He crosses the river taking shortest path. I'm writing in short. He takes 12.5 minutes. Find what we have to find out, width of river is W. Second, velocity of boat with respect to a river, VBR, right? And velocity of river, third. Dear students, the problem is that this is a problem. Let it is a river, has a width W. The two type of problem is asked, that how a person should travel, that he crosses the river in minimum time, and he crosses, and another type of question might be that he crosses the river through the shortest path. The two kind of questions are asked, that how the man should travel, or how the boat should be sailed, that it should cross in minimum time, or it should cross along the shortest path. These two are very, very different things, right? First is in minimum time. If man wants to cross, or boat wants to boat crosses the river in minimum time, means for the minimum time boat is traveling with respect to river perpendicularly, right? If it wants to cross the river in minimum time, then the boat will sail perpendicularly from A to B in this direction. This is the condition for the minimum time. If a man wants to cross the river in minimum time, he has to swim perpendicularly. Let the boat reaches here, rather it reaches to B, it will be drifted because of river, right? It will be drifted up to point C. So it is the drift, right? And so the man sitting here observes that the boat does not reach to B, but rather it reaches to point C. So it is the velocity of boat with respect to ground, right? And river is flowing in this way, so it is the velocity of river with respect to ground. Now, dear students, what it is given that in minimum time the drift is at 120 meter, and in minimum time it crosses T minimum is equal to, that is the minimum time taken by the boat to cross the river is 10 minutes. If you have the velocity of boat with respect to river, then you can directly find T is equal to W upon VBR, right? But W is also not given. Now look here, dear student, why this drift comes? It is because of flow of the river, right? So the drift is equal to, you can say, distance is equal to velocity into time, right? And velocity is what? Velocity for the drift, horizontal drift comes y. Why the boat is drifted horizontally? It is because of flow of river. From this figure, it is clear that horizontal component of velocity is governed by only by river in this case. So because boat is swimming with respect to river perpendicularly, so its horizontal component is 0. So the horizontal, in simple words, in this case horizontal drift comes only because of river. So D is equal to, horizontal drift is equal to velocity of river into time, that is minimum time, and drift is a 120 meter, right? And velocity of river, T minimum is at 10 minutes. So VR is equal to 120 by 10, that is 12 meter per minute, right? The drift was 120 meter and the minimum time in crossing the river is at 10 minutes. I have discussed the condition that how it will cross the minimum. In minimum time, if you want to sail, you want to cross the river, you have to travel, you have to swim perpendicularly. Boat has to sail itself perpendicularly to the river. Only in that condition it will take minimum time. So the drift is equal to, in meantime, rather with respect to ground, boat, yet it is sailing perpendicularly to the river, but it will not reach to point B, rather it will reach to the point C. So it is a drift, and drift is equal to velocity into time. How much time it has taken in crossing the river? That is 10 minutes. And the velocity is what? Horizontal drift comes because of horizontal velocity, and horizontal velocity in this case is the velocity of river. So you have find out velocity of river, that is 12 meter per minute. One problem has been solved. Now for the shortest path, what is for the shortest path, the time taken is a 12.5 minutes. Means shortest path means it has to reach here. Condition, whatever condition you have to apply. Time taken, this is not a minimum time. The basic condition is, your motto is you have to cross this river in the shortest path. right? So you have to reach from A to just opposite to the opposite point of river bank, opposite point of A, means you have to reach B, whatever time taken is. But when you reach it from A to B, time taken is 12.5 minutes. So time taken, the minimum time taken means you travel in this way perpendicularly to the river, wherever you are drifted, no matter, but time taken is at 10 minutes. But when it is said that you have to cross through the shortest path, you have to come here in whatever is the direction you travel in, whatever direction the boat sails, it does not matter, you have to sail from A to B. In that sail, in that process, time taken is at 12.5 minutes. Now the two things we have to find out this, right? Now look here, dear student. Velocity of river you find out, and that is it. Velocity of river works out to be 12 meter per minute. Now look here, for the shortest path, time taken is that much and this is that much. Now look here, again, this is B. Let boat swims with respect to river at an angle theta, right? Boat swims with respect to river at an angle theta. And now this time you have found out VR is equal to 12 meter per minute, right? We find out 12 meter per minute. And now you have to find out the two things, that how much wide the river is, and second, what is the velocity of boat with respect to river. In the first condition, you have find out that the velocity of river is at 12 meter per minute. And that was the condition, look here, that was the condition. In minimum time, it is a case first, you can say. Both the cases will be on the board. It will be easy you to understand. Dear student, in first case, the minimum time is 10 minutes when boat travels with velocity. Boat swims with respect to river perpendicularly. T minimum is 10 and boat reaches here. It is a velocity of boat with respect to ground, and it is the velocity of river, and drift was that much. With this, we have find out, that is what we find out, velocity of river, that is 12 meter per minute. Is anything more you can find here? Yes, you can. Look here, the time taken in crossing the river, T is equal to D upon VBR. Also you can find out here. And T is what? T is, look here, 10 minutes. Let it is D upon VBR. Or you can write D is equal to 10 VBR. Later on we will use that. Dear student, look here. How much time taken? Time is equal to distance upon perpendicular component of velocity. That is, right? T is 10. 10 is equal to D upon VBR, or D is equal to 10 VBR. Now look here. In the shortest path, for the shortest path means it has to travel from A to B. The boat has to reach at point B. Whatever condition you apply, it depends on the swimmer, it depends on the sailor, right? Let the boat with respect to river begin to sail, right? At an angle, the boatman begin to sail its river at an angle theta from the vertical, right? So time taken will be very simple. Distance upon vertical component of velocity, that is VBR cos theta. Time is equal to T is equal to D upon VBR cos theta. Now look here, this time is given, dear student, or D upon VBR cos theta is equal to 12.5, right? D upon VBR cos theta is equal to this 12.5, right? Now, dear student, we can apply the condition that here D is equal to 10 VBR. You look here, D is equal to 10 VBR. This condition you can apply here. How? Look here, D is equal to 10 VBR upon VBR cos theta, that is equal to 12.5. Dear student, this will be cancelled. Cos theta bring here, cos theta is equal to, cos theta I have brought here, so 12.5 will be 10 upon 12.5. So the 4 by 5. Now in this triangle, look here, this is theta. Cos theta is equal to base upon hypo 4 by 5, so it is a 3. Sin theta is equal to 3 by 5. Now, dear students, we have find out that what we find out? The value of theta we find out, right? Sin theta is equal to 3 upon 5. Now, what we have to find out? Velocity of river we find out. And now, time taken we have to find out. Now, dear student, the condition is that man has to reach from A to B. It means the horizontal component of velocity should be 0. Only then it can reach from A to B. So, what I'm doing here that the net horizontal component will be VR, or you can say VR is equal to VBR sin theta. That should be VR is equal to VBR sin theta. This component will be away from the angle, that is VBR sin theta. So VR is at 12. VBR sin theta is equal to 3 by 5. 3 4 ja. So VBR is equal to 4 5 ja. This was 4 5 ja. 20 meter per minute. So this is a 12 meter per minute, fine. This was from 12 meter per minute. Now dear student, third component that you have to find out W, or the width of river. How will you find out, right? From here, in this VBR you are given, so D is equal to 10 VBR. 10 VBR is what? Just you have find out 20 meter per minute, so it is a 20. So this is a 200 meter. In this way you can solve it easily, right? Dear student, I have tried my best to explain you these problems, and I hope you all are following. Might be some problems, sometimes there might be a difference in communication, but I will try my best. And least but not last is my request to you all that if you think that my videos are working with you, if I'm capable of explaining the basics of physics, then please like, share and subscribe my videos, and must put bell icon so that you can be informed about my new videos. Thank you. Meet you in next video.